Okay, hi everyone. This video is going to focus on the introduction to empirical and molecular formulas. So first of all, we want to go ahead and think about what these two things are. So if we think about the example butene, and I have the structural compound listed there, we have two different ways of describing it. We have the molecular formula and we have the empirical formula. So in this case, the molecular formula would be C4H8, which counts for the fact that we have 4 carbon atoms and 8 hydrogens. The empirical formula for this compound would be CH2. So the molecular formula is also known as the true formula. It tells us exactly how many atoms of each element we have. Versus the empirical formula is a simplified version of that true formula. Molecular formula, like I said, tells exactly how many atoms of each element we have, and it's shown using subscripts. And in the case of the empirical formula, the subscripts show the ratio of the elements. Now, it's important to note that sometimes the empirical and molecular formula can be the same, but that's not always true. Okay, so let's go ahead and work through an example. Here we have cyanuric triazide, which the molecule is shown here. The blue spheres are nitrogen atoms, and the dark gray ones are carbon atoms. So the molecular formula, remember that is the true formula. If I count it up, I have 3 gray spheres, and then I have 12 blue spheres. So the molecular formula is going to be C3N12. Now the empirical formula, remember that is the reduced form, or the reduced lowest whole number ratio. So that one would just be CN4, meaning for every 1 carbon atom, I have 4 nitrogen atoms. Okay, so let's go ahead and try this out with an example. We want to determine the molecular formula of a compound with the empirical formula of CF2 and a molar mass of 200.04 grams per mole. Well, we know the empirical formula is the lowest whole number ratio. So it could be CF2 or could be some multiple of CF2. So it could be C2F4 or C3F6. We're going to find that out. So a good step always when we're given molar mass is to calculate the molar mass of our compound. So we want to find the molar mass of CF2. Remember, we take 1 times the mass of carbon plus 2 times the mass of fluorine, and we add that all up, which gives us a molar mass of 50.01 grams per mole for CF2. Well, let's go ahead and work through our options. Like I said, the first one, CF2, that's going to have a molar mass of 50.01. Well, that doesn't quite match our molar mass of our 200, so we're going to keep going. If we take our empirical formula and multiply by 2, I get about 100. If I take our empirical formula and multiply it by 3, we get 150. And then if I take our empirical formula and multiply it by 4, I get the magical 200.04. So we know that our molecular formula must be C4F8. Okay. Now, you know I am all about the shortcuts. I like to make life easier when possible. So instead of setting up those tables, there's a faster way to figure this out. So in order to find the molecular formula, we're going to take the molar mass of the molecular formula, which is at 200 that was given to us, and we're going to divide it by the molar mass of the empirical formula, which is about 50. So if we divide those, we get a value of 4, and then I can go ahead and just multiply CF2 by 4 to get my molecular formula. So a little bit faster than having to set up those tables and work through it step by step. Okay, so when finding the molecular formula, I don't think this is in your notes, so please make sure to go ahead and add it. Write this down. The first step is we want to find the molar mass of the empirical formula. Next, we're going to divide the molar mass of the molecular formula, that total one, which will always be given to you, by the molar mass of the empirical formula, the thing you found. And then we're going to multiply the empirical formula by the number that we found in the previous step, whatever that is, whether it's 1, 2, 10, 20, whatever it is. Okay, so let's go ahead and work through some examples of this. Okay, so let's work through some examples. The first one, we need to calculate the molecular formula of a compound with the empirical formula of C2H2O and a molar mass of 126.12 grams per mole. So the first thing we need to do is find the molar mass of the empirical formula, that's C2H2O. So you're going to need your periodic table, and we're going to find the molar mass of each element. So for carbon, I have 2 of those, and carbon has a molar mass of 12.01. Again, just remember, different periodic tables will give you slightly different molar mass values. That is okay. Hydrogen, I have 2 of those, and it has a molar mass of 1.01. So that's 2.02. And this one's 24.02. And then oxygen, I have 1 of those, and it has a molar mass of about 16. So to find the molar mass of the whole compound, I'm going to add up the molar mass of each of those components. So 24.02 plus 2.02, and then plus 16. So that gives me a molar mass of 42.04 grams per mole. Okay, and when I compare this value to the molecular formula molar mass, which is 126, I see they're not the same. I'm guessing it's going to be about 3, but let's go ahead and actually check it out. So we're going to take the molar mass of the molecular formula, and that's always the thing that's given to you, and we're going to divide it by the one that you calculate, so 42.04. So if I put that into my calculator, 126.12 divided by 42.04, that gives me exactly 3. Okay, so I know I need to take the formula of the empirical formula and multiply it by 3. So I'm going to C2H2O, and I'm going to multiply that by 3, which gives me C6H6O3. Okay, so that is my molecular formula. Okay, let's go ahead and try another one. Okay, a compound has the empirical formula C2H5N and a molar mass of 86.16 grams per mole. What is its molecular formula? Okay, so again, I start by finding the molar mass of my empirical formula. So I'm going to take 2 carbon, plus I have, in this case, 5 hydrogen. And then for my nitrogen, I have 1 of those, and that has a mass of 14.01. So I'm going to go ahead and add those all up. So 24.02 plus 5.05 plus 14.01. So that gives me a molar mass of 43.08 grams per mole. Okay, now to find out its molecular formula, we're going to take the molar mass that's given to us, so the 86.16, divided by the one we calculate, which is 43.08, and that gives me exactly 2. So I'm going to go ahead and double the empirical formula to get to the molecular formula. So C2H5N, I'm going to multiply that by 2, which is going to give me C4H10N2. Okay, so let's go ahead and try one final example. Calculate the molecular formula for a compound with the formula C2HF and a molar mass of 264.18 grams per mole. Okay, so again, start by listing off all of your elements. I have carbon, hydrogen, and fluorine. I have 2 carbon. So that gives me 24.02 for the carbon contribution. I have 1 hydrogen in this case. So that's easy enough, 1.01. And I have 1 fluorine, and fluorine has a molar mass of 19. So if I go ahead and add those all up together, I get 24.02 plus 1.01 plus 19. So that gives me a molar mass of 44.03. Okay, so I'm going to go ahead now and divide the given mass, which is the molar mass of my molecular formula, so 264.18 by the one I calculated, the 44.03. So 264.18 divided by 44.03. And that gives me 6. Okay, so I'm going to go ahead and multiply my empirical formula by 6 to get my molecular formula. So C2H F, I'm going to multiply that by 6. So I'm going to get C12H6F6. Okay, so I hope that helps. If you have any questions, please go ahead and let me know. Bye, everyone.